Okay, in this video we're told that during a snowstorm, a meteorologist tracks the amount of accumulating snow. For the first 3 hours of the storm, the snow fell at a constant rate of 1 inch per hour. The storm then stopped for 2 hours and then started again at a constant rate of 1/2 inch per hour for the next 4 hours. On the grid below, draw and label a graph that models the accumulation of snow over time using the data the meteorologist collected. So here we've got a piecewise function because we've got these three different rates that describe the situation we're dealing with. And a function, f of x, right, can be written as piecewise in many different ways. I like to set these big brackets up. And what they're telling us is that for the first 3 hours of the storm, so let's say x will represent the hours, and y will represent the accumulation of snow, or the snow accumulation. So here, f of x is another way of saying y. So the amount of snow, y, or f of x, depends on how many hours into the situation, or into the storm that we are, right? So here for the first 3 hours, I fell at a constant rate of 1 inch per hour. So here that means if we're starting at 0, 1 inch per hour is just 1x, right? Our slope is 1, and that's when x is between 0 and 3, the first 3 hours of the storm. Then the storm stopped for 2 hours, right? And then started again at a constant. So we'll come back to that piece right there, but basically after 3 hours, right, if you plug in 3 to the first formula, you're at 3, right, inches. And then it stays at 3 inches for 2 hours, so from the 3rd hour up to the 5th hour. So that time until right there, there's no accumulation, right? It just stays at 3. And for the next 4 hours, so that's from 5 through 9, what's happening is that it's going at 1/2 inch per hour. So here the equation will be a little bit trickier. It won't exactly be 1/2 x, right? Because it's not proportional. We have to find the y value, right, or the y-intercept that goes there. They're not asking for any of this, but I think it's good to have this to supplement what we're doing, because what we're doing first of all is graphing, right, x versus y. We're graphing hours versus snow accumulation. So here's my x-axis right here. Choose a different color, sorry. So x-axis and y-axis. I'll move that over one so I can label it. Okay. So here, right here on the x-axis we have the hours that have passed, and then here on the y-axis we have the snow. That's me writing vertically snow. So for the 0, 1, 2, 3 hours, that's the first part of the storm, the snow accumulates at 1 inch per hour. So for the first hour there'll be 1 inch, and then the second hour there'll be 2 inches, and the 3rd hour there'll be 3 inches. That's y equals x, right? That first formula that we have. F of x equals 1x, same thing. So here, that's the first 3 hours, and then we said before, right, that it stays at that height until over the next 2 hours. So here's 4, and then 5 hours in, it's going to stay at this height. So I'll label a different color here, right? Oops, that's not really level. There we go. And then what happens? Well, it's at 3 inches here, 4, 3, 5, 3, and then it climbs again, but now it's climbing at 1/2 inch per hour, and that's for the next 4 hours. So we have 6, 7, 8, 9, right? That's 9 hours into the storm, and it's 1/2 inch per hour. So if I go up 1 hour, to go up a half. If I go up 2, it's hard to graph a half here to get it exactly. So instead I'll go up 2 hours, which brings me up 1 full inch, right? And then the next 2 hours will bring up another full inch. And what I would do actually is just go the whole way. Then, you know, if 2 hours brings you up 1 inch, then 4 hours brings you up 2 inches. Drawing that one line looks a lot neater there. So here, right, we have our graph. And just for fun, let's figure out the equation of this line. Y equals 1/2 x plus b. Well, just pick a point in that line, plug it in, and we can get the equation for the line. So I'll pick, we can pick this point, nice friendly point to read. We have 9, 5 as well, that's fine, so we'll pick that one, 9, 5. So remember what you can do, 9, 5, 9 is x and 5 is y, and those values will balance this equation. So we can plug those in. So 5 equals 1/2 of 9, so 5 is equal to 4.5 plus b. So then what does b equal? Well, b will equal 1/2, right? So here, the equation, when we go back to this step, what we can write is 1/2 x plus 1/2, right? That's the equation for that line. Now this, when you're setting this graph up, all you need to really do is set up a title, snow accumulation, and really just, of course, make sure your graph is nice and neat. Label points if you can to really help you, and label the axes. If the snowstorm started at 6 p.m., how much snow had accumulated by midnight? Well, here, right, how many hours are there from 6 p.m., right, to midnight, which is 12 a.m.? Well, here we can just do the subtraction, right? Because if we're going from 6 p.m. to 7 p.m., that's 1 hour, and 7 minus 6 is 1. So here, 12 minus 6 is 6 hours. So we have 6 hours of accumulation. And they want to know, well, how much snow would that be? Okay, so here, we're going basically up until the 6th hour. That's this point right here. And really, all you have to do is kind of read the graph. You look up and look over here to see what's happening. And at 6 hours, we're at 3.5 inches of snow. So it's 3.5 inches, right? And to make sure it was inches here. Yeah, that was inches. Okay, thanks.